Bismillahirrahmanirrahim. Assalamu alaikum dear students. I am Arif and I welcome you all to the next session of System Programming with Linux. Today we are going to design and code our own Linux shell. Well, this slide shows the agenda of today's session. First of all, we will see what is a shell program in Unix. Then we will discuss what does a shell program actually do. And then we will try to understand how does a shell do it. And finally, we will start writing different versions of our own shell program. Well, dear students, we have been using the famous bash shell in this entire course, and most of us know what it is and what it do. But for the completion's sake, let us have a quick recap of the features of a bash shell. And let me straight away move on to the Linux terminal and see first of all what are the different types of shell. Well, the most famous shell is the bash shell. Please do see the man page of this shell. Then we have the bone shell, which is now the dash command interpreter. We have the C shell. We have the TC shell. We have the cone shell. And we do have Z shell. And there are a lot of other shell programs. Well, right now the shell program which is running is having the ID of 20239, and let me do ps-l with this process 20239. Well, dear students, to Richard Stevens, who is the author of the book Advanced Programming in the Unix Environment, shell is a command line interpreter that reads user inputs and executes those commands. And to me, in the simplest words, a shell is a program executing another program. And the way this is a shell program, which is an interactive program and prompting me for an input, and I give the input like, let's suppose ls-l/home, and once I press enter, the bash program executes the ls command. So this is what a bash program is actually. We can always execute multiple commands in a single line by separating them with semicolons, like ls post date pwd. These are the three commands. You can see the output of ls, date, and the present working directory command. Well, there are two main modes of a shell, interactive and non-interactive. Right now we are working in interactive mode, in which a user interacts with the shell by giving commands and see their results on stdout. In non-interactive mode, the shell reads a text file containing shell commands, and normally that file is called a script file. The shell executes those commands in sequence until it reaches the end of the file. Let me show you a basic script file. This first line over here, which starts with the #bang sign, is not a comment. It is a magic line telling the type of the shell program to use for the execution of this script. And let me execute this script, and you see all the commands are executed one after another. Well, dear students, the shell commands that we normally execute are categorized into two main types, the internal and the external commands. The internal commands are also called the shell built-ins. The code of the internal commands are actually part of the shell. You can use the help command to view the list of all internal commands. Let me do that. You see, these are the list of the commands, like this history is an internal command, bg is an internal command, cd is an internal command, and so on. You can always use compgen command to list the internal commands. Let me less it. So these are the list of all the internal commands that the presently logged in user can execute. Some of these you might have used in the previous sessions. Okay. Oh, well, dear students, some commands have both internal and external versions, like the echo and pwd. Let me check out. Type -a echo and type -a pwd. So both these commands have both the versions available, the built-in as well as the external. When you execute these commands, the internal version takes the priority, and to execute the external version, you must give the absolute path to the command. And in case if you want to get help about some internal command, you can use help, and then you can type out the name of that internal command. So exit is an internal command that is used to exit the shell. Fine. Enough for the internal commands. Let's talk about the external commands as well. Students, a command whose code resides in a binary file on disk is an external command. And to execute an external command, the shell spawns a child process and then overwrite it using the exec call. To see a list of all internal and external commands that a user can execute on the shell, we can again use the compgen-c. Remember, -b is the option for displaying the internal commands. This is a huge list. You can see the ls is there, the getconf, gcc, a lot of internal commands you can see over here. The external commands are also here. Okay, fine. And to get help about any of the external command, of course, you can use the man page, the man command, which displays the man page of that particular command. Okay, well, a shell also gives you the power to run your commands in the background by placing the ampersand character at the end of the command line. For example, let me run the sleep command for 1000 seconds and run it in the background. And if you want to bring a background running job to the foreground, you can do so by the internal command fg and by giving it the job ID. You see the sleep is now running in the foreground. And to send it again to the background, you first need to suspend it by pressing the Ctrl+Z character. Now it is stopped. And if you want to run it in the background, you can use the bg command with percentage and job ID. Now it is running in the background. You can check it out. Sleep is running right now. And once again, if you want to bring it to the foreground, you can use the fg command. Now it is again in the foreground. Let's terminate it. So this is what job control is. Making the jobs run in the foreground, background, and sending different signals to them. Okay, dear students, another feature of the bash shell is the name completion. It gives its user the facility for name completion for commands as well as for files. For example, let's suppose that I think there is a command that starts with G, and if I press a double tab over here, it will show me all the possible commands that start with a G. So these are the commands that start with G. And if I know the other character, and now if I press double tab, it gives me less number of commands. And if I know the third character as well, and now it will give me less number of commands. And again, if I press tab, it automatically completes the command name. So let's suppose genome-calculator is the command which I want to run. Pretty fine. The way bash shell completes the command names, similarly the bash shell completes the file names as well. Let's suppose I want to open a file which is there in the etc directory, but I don't know its name. If I press double tab, it will tell me that there are 334 possibilities. That is, there are 334 files in this directory. Let's suppose I say the name starts with a P. Now if I press double tab, it showed me all the files in etc directory whose name starts with a P. And of course I want to see the password file. Pretty fine. Okay, another feature is the history. Bash shell maintains the history of the shell commands executed by a user. About 1000 previous commands are kept in memory, and when a user logs out, these commands are written in a file. That is the .bash_history in the user's home directory. And you can always access the previous commands in sequence by pressing the up arrow. I'm just pressing the up arrow, and you can see all these commands are being displayed to me. Okay, and if I want to see all the commands in the history, so I can run the history command. So these are the commands which I have executed. And if you want to execute a particular command, let's suppose that I want to run this command, man wc, having the number 2202, I can use the bang sign and then I can give the number 2202. So this command will be executed immediately. Similarly, if I just want to run the previous command, I can give a double bang sign, and here we go. Oh, well, after the history, another feature of the shell is powerful feature is the IO redirection. It allows the user to redirect the standard input, standard output, and the standard error stream using the redirection operators. We have seen this before as well. Let me write this command. What this command is going to do is it will attach the std in of this cat process with this file, the std out of this cat process with this file, and std error of this cat process with this file. And if you do an ls, you can see this file op.txt and err.txt are created. Similarly, if I do something like this, 2 greater than &1, this command will attach both the std out and std error to the file op.txt by the use of copy descriptor. If you want to see the details, please see the video session 8 on IO redirection in the operating system with the Linux course. Other than the IO redirection, the related powerful feature of the bash shell is the use of pipes using the pipe operator. Let's suppose I do something like this: unzip a file which is usr share man1 ls.1.gz, and let me send the output to another program, that is, let's suppose cat, and let me grep ls from there. Well, the input of this program is redirected to this file, so gunzip will read this file, and this is a pipe, and the output of this gunzip program will be sent to this program. This cat program will receive its input from this pipe and send its output to this pipe, and this grep will read its input from the input end of this pipe and send its output to std out. So this entire command will just display only those lines in the main page of ls which have the string ls in them. Okay, so these are the lines. You can see in every line we have an ls over there. And if I output this, pipe this output to another program, that is wc, you can see that there are a total number of 11 lines over here. Okay, dear students, another powerful feature of bash shell is that you can define variables over here. The shell variables come in two flavors, the environment variables and the user defined variables. Environment variables are used by the UNIX systems to personalize different system settings and configurations. Let us view these variables using the set command, and let me pipe output to less. Well, most of these variables are initialized with default values. However, users can change them to suit their needs. A copy of these variables are passed to every command that a user executes on the shell. And let me search for variable ps1. I can find this is the primary shell prompt. ps1 is the primary shell prompt which we normally see on the shell. ps2 is a secondary shell prompt. It appears when a command extends on the second line. We can extend a command on the second line by placing a backslash character before the new line character. And the default prompt for ps2 is this greater than sign. ps3 is not here. By default it is empty, and actually ps3 is used to hold the menu prompt for select control structure, and this ps4 is used for the debugging prompt, normally when we use gdb, and its default is plus. We can always change the value of these environment variables. Okay, the other category of shell variables are the user defined variables. For example, let me define a variable name with the value of Arif but, and let me do echo learning is fun with $name, and once I press enter, you see this dollar followed by the variable name is substituted by the value of the variable. And if you want this variable to be available for all the child processes of this shell, you of course need to export it. Okay, well, bash shell has a strong support for the operators as well, and let me talk about the arithmetic operators first. And the arithmetic operators are plus, minus, division, and for multiplication we need to prefix it with the escape sequence, because star is used for file globing as well. So these are the arithmetic operators, and let me use them by using the command expr to evaluate an expression. 5 plus 4, so it is 9, and let me multiply 5 with 4, we get 20. Okay, other than the arithmetic operators, we have the numeric comparison operators, and these are the equal to, is not equal to, is greater than equal to, is less than, and is less than equal to. So these are the numeric comparison operators. To use them, we need to use another operator, that is the straight bracket, which is an internal command used to evaluate conditional expressions. For example, let me say 5 is not equal to 6, and let me check the return value of this command from the environment variable $? So it is 0. 5 is not equal to 6, it is true. So on the successful execution of a command, the shell returns 0, and if I say is 5 is equal to 6, this time we get a 1, that is false. Remember, whenever a command is a success, it returns 0, and whenever it is a failure, it returns 1. The way we have numeric comparison operators, we have the string comparison operators as well, like the is equal to, is not equal to, hyphen and hyphen n and hyphen z. Hyphen n is used to check if size of a string is non-zero, and hyphen z is used to check the size of the string. If the size of the string is 0, then it returns true. Let me use this again. Let me compare two strings. Let's suppose Arif is equal to Rauf, and if I check out, it says that Okay, so I need to use the string comparison operator over here, that is equal to. So it says false, Arif is not equal to rows, and if I use not equal to over here, it will return true, that is 0. Other than string comparison operators, we have the logical operators, which are not, logical not, logical and logical or. Okay, so let me say true and false, and of course this will be false. Let me do echo dollar question mark. So this is of course false, returns 1. And if I do logical or, so true or false is of course true, so we get a 0 over here. That is great. The last operator I want to touch upon are the file operators, and there are different file operators that we can use in bash, like -f, -d, -c, -b, -p, capital S, and -h. These 7 operators are used to test the type of the file. For regular files, for directories, for character special files, for block special files, for named pipes, for sockets, and for symbolic links. And if you want to check out for the permissions on a file, you can use -r, -w, and -x. And if you want to check out whether the SUID bit of a program is set, you can use this flag, this operator. And if you want to check out that if the SGAD bit is set, you can use this. And for sticky bit, you can use this. Okay, let me show you an example. Let me check out whether this is a regular file or not. Echo dollar question mark. Well, yes, this is a regular file. And what if I want to check out whether this is a directory or not? And of course, this is not a directory. However, this is of course a directory, so it returns true or 0. Okay, programming ability. Another powerful feature of bash. It supports non-sequential execution using the if-else and the loop structures. Okay, let me clear screen and run an if-else structure. Let's suppose if @cpass wd is a file. If this is true, this is a secondary prompt. Then I say then echo passwd is a file, else echo passwd is not a file, fi. Okay, so if this will be evaluated, if this will be evaluated to true, then this command will be executed, otherwise this command will be executed. And of course we know pass wd is a file. Well, there is a case statement as well in bash shell that can be used instead of a long if else. Search is used at your own. And let me move on to the loop construct in the bash shell for ctr in, let's suppose 1, 2, 3, 4, and 5. And let me do what? Do echo $ctr, the value of this variable, and let me do done. And you see it is printed. Please do see the while do done and the until do done loop constructs at your own. And let me fall back over here. Well, dear students, we have seen what does a shell do very quickly. Now I want to know how does the shell actually do it. Well, the shell displays the prompt, read the command line string, tokenizes it. If it is a control command, for example, a IO redirection operator or a file operator or something else, it handles it. If it is an internal command, it executes the code which resides, of course, within the code of the shell. If it is an external command, a child process is forked and exit with that command. And while the child executes, the parent process wait for the termination of the child. And after the child terminates, parent process go to step 1 again. That is display the prompt and get the next command line. Well, one of the main tasks that we need to do while we design our own shell is tokenizing the command string. So on the shell, a user normally gives a command like this. And this command needs to be tokenized. For example, this first token is assumed to be a command, this next token is assumed to be an argument to this command, and then we have a null over here. And similarly over here we have 3 tokens. The first token is a command, then we have the option to the command, and the third token is the argument to the command, and then we have the null. Okay, so fine, let's start coding. But instead of jumping straight away on writing the version 1 of our shell, I have written some sample programs that will make us progress gradually to this version. Let us move on to the Linux terminal and start coding now. Let me clear screen and let me do vim temp1.c. Right, dear students, this is a very basic program that creates an argument list and then calls execvp. And we know that the exec family of function replaces the current process image with a new process image. This execvp function is passed 2 arguments. The first is the program name, which will be searched in the directories mentioned in the path environment variables. And this second argument is the list of the command line arguments with a terminating null string as shown over here. So once this program will execute, it will execute actually the command ls-l/home. Let me compile this program, gcc temp1.c, and let me run it. Well, that's great, and let me run the command, otherwise both are giving us the same output. Well, the limitation of this program is that the user can't run a program of his own choice. If I run this program again, it will again execute the same command, that is ls-l/home. I run it again gives the same output. What if I want to execute commands of user's choice? Let me show you another program, temp2.c. Okay, so this program now creates a list for 3 strings, an arg list for 3 strings, each of size 10 bytes, and those 10 bytes are allocated onto the heap. So we have 3 strings, each string of 10 bytes on heap. And over here it is prompting the user to enter something in arg list sub 0, which should be the command, and then arg list sub 1, which should be the argument to the command. And then it places a null at the 3rd place and finally calls execvp with the command name and the arg list. Fine, I hope this is simple. Let me compile and run this now. gcc temp2.c ./a.out, and you see this time it is asking me for the command. Let's suppose that I say ls and I say /home. So it gives me the listing of the /home. Let me run it again. Let me say ls and let me say -l. So it gives me the long listing of the present working directory. Let me run it again. The limitation of this program, as you can see, is that I can only run a command with 1 argument. I even cannot run a command without an argument. For example, I just want to run a date program. I can't run it. Okay, so this program is again not good. That is, I can't run a command with 2 arguments, for example the cp command, and I cannot run a command without any argument, for example the genome calculator or the date. Let's see another program now. Vim temp3.c. Okay. So this program now asks the user for the number of words or tokens that the user think are there in the command. So it is first asking me for the number of tokens or number of words in my command, and then it is allocating appropriate memory for that much amount of memory is to store that much number of strings, and over here it is assuming that every string will be of 10 characters including the null character. It then enters in a loop to get the command and its argument, and of course it will run max args number of time, which I have given over here, and finally it will call execvp to execute that command. Okay, so let me compile and run this program now, temp3.c. Okay, so since I want to run the command genome calculator, so I say I just want to enter one word, and that is genome -calculator, and it executes successfully. Pretty fine. Let me run it again, and this time suppose I want to run the cp command, and the cp command having two arguments. The command name is cp. The first argument name is, let's suppose, the name of this file which is there in the present working directory, and I want to copy this to another file, that is abc.c. Let me press enter, and if I do an ls, you can see the abc.c over here, and if I do cat abc.c, so this is the same file. That's great. Okay, so dear students, wouldn't it be better if I just write a space separated string containing 1, 2, 3 or whatever number of command tokens or words, and that program appropriately allocate memory for that string. It tokenizes it and pass the tokens to the execvp function later on. If I can do like this, it will be great. So let me show you another program, temp4.c. This is what is going to solve the problem. Let me make you understand this code. Well, over here I have defined three constants: max length 512, which is the maximum length of the command string that I'm going to enter. Max args 10 is the maximum number of tokens or words I'm assuming will be there in the command string. Arglen 30, the maximum size of each token. Okay. Over here, this is the main function. The main function calls another function, that is read command, which gets the command string from user and returns it. The main function then calls the tokenize function, which tokenizes the command string and returns those tokens. And the main function then passes this arg list to the execvp function for the execution of the command. So that's great, quite simple. Let us see the code of the read command function now. Let me move down. So this is the read command function. It receives, of course, the std in input stream. Read command is receiving the input stream. And what it is doing, it is actually first of all allocating memory on the heap for 512 bytes to store the complete command string. Okay, this while loop is actually getting the input from the user character by character until the end of file or the new line character is encountered, and it places that character which is there in this variable C in this command line, and this position is incremented for every new character. And finally, once we press enter, this loop breaks and we places a null at the end of the string, and we return this complete command line to the main function over here. That is great. The main function then passes this command line to this function tokenize, which creates token of this entire command line. Let me see this token function now, tokenize function. Okay, excuse me. Well, this tokenize function, first of all, it allocates memory for 10 words, and each word of arglen over here, which is 30 bytes, and this B0 is actually a function that initializes all the words with null characters. So this is just memory allocation over here. Well, over here, this entire piece of code is actually tokenizing the string pointed to by this command line and places them in arg list sub 0 and arg list sub 1 and arg list sub 2 and so on. And it tokenizes it based on spaces. Well, if this appears tricky to use, you can use strtalk function of standard C library, which is used to extract tokens from a string. So finally, this tokenize function tokenizes all the words and sends them back to the main, and the main function calls execvp. Let me compile and run this piece of code. gcc temp 4.c. Okay, so now I can enter any command of any length. Let's suppose genome hyphen calculator. So a single word command works fine. Let me run the program again, and let me say cp temp 4.c copy file.txt, and you see this copy file.txt is created. Let me run this program again, and let me say ls -l/home, and you see it is running, and that works great. Okay, dear students, now I think it is time that you should sit down and write the first version of your shell program. I have written it for you. Let me show the code. The code is very simple. You will be able to understand it quickly now. Well, we know that a shell program actually executes commands by first doing a fork to create a child process and then do an exec in the child program. The child program executes and the parent wait, and this process is of course repeated. Okay, so this is the main function. This program now runs in a while loop, which is shown over here, and this while loop continues its execution. Read a command string, tokenizes it, and then calls a function execute with all the tokens in the argument list. So this while loop calls a read command function, tokenize function, and then calls the execute function. This read command and tokenize function are the same which we have seen in the previous temp4.c file. This is the execute function. Let me show you this execute function. Okay, so this execute function is passed that tokenized list. It performs a fork. In case of error, do this. This case 0 shows the child process, and we know that fork returns 0 in the child, and in the child we call execvp with the arg list sub 0, and this is a piece of code which the parent will be executing. So the parent calls wait PID, and it waits for this child whose PID is received inside the fork, and the return value of the child process is received in this status, and finally it displays that the child exited with this status. And after the execution of this, it falls back over here inside the main, and this piece of code is important now because we need to free all the memory that we have created in the read command and the tokenize function. And finally we again fall back over here and read the next command. And let me show you the there is a bit difference in the read command. We are passing it two arguments now. One is the prompt, and the prompt is whatever you write over here, and the read command is actually well, the read command is just displaying that prompt. The rest of the code is same. Let us compile it. My shell v1.c. Let me execute it. Wow. So this is the shell which we are working on now. Interactive, continuously running. Let me execute a command that is clear. Let me do ps-a. Let me do clear. Let me do ps-f. So this is not the actual shell. This is my shell which we just have written. Let me run genome-calculator, and you see the calculator is there. Let me multiply 8 with 2 to get 16. Let me close it, and we are back on the shell that we have written. Let me do ls-l/home. The program has created a child process, executed with ls with the appropriate arguments. The parent waits, finally parent prints the exit value of the child, and here is the shell program which we have written. Let me run another command, my favorite character Kakamanna, and it says command not found, and of course this command is not there. Okay, well dear friends, let's fall back to the slides. Well, this part is over. Dear students, after you have yourself written the first version, I hope you will be able to do the remaining 7 versions which I am leaving as an assignment, and whose deadline is 2 weeks after the uploading of this video. So in version 2, what you need to do is you need to add some internal commands to the shell, like the cd, exit, jobs, and help. Remember, the code of these commands will be the part of the shell code. The version 3 actually has the feature of the input and the output redirection, and it should also add the functionality of the pipe operator on the shell. This version 4, it will enable the user to run multiple commands on a single line separated by semicolons, which we have seen in the initial part of this video. And moreover, this version should be able to execute commands in the background if the command is followed by an ampersand operator before the new line character. This version 5 should add the feature of maintaining command history and accessing them using this sign exclamation followed by the number of the command, or maybe using the up and the down arrow keys you can access the previous command and execute them. In version 6, you need to add the functionality of adding a basic if control structure, which works as follows. The shell runs the command that follows the keyword if. The shell checks the exit status of that command, and if it is a success, that means 0. So it executes the true path, and if it is a failure, it executes the false path. And the keyword fi marks the end of the if block. We have seen this as well in the initial part of today's session. Well, this version 7 adds the feature of creating, accessing, and modifying variables within your shell. And finally, this feature adds the feature of a file or the command name completion when you use the tab key as we do in the normal bash shell. Well, you can use the GNU readline library to make it simple for you. Okay, so that is all for today's session. Dear students, I hope it was informative for you all. If you have liked it, please subscribe my YouTube channel and share it with your friends. See you next time. Wish you all the best, happy learning, and Allah Hafiz.